So in this video, we'll be going over the example of a child swinging a rock. And so we have a child swings a 100-gram rock tied to the end of a 0.6 meter long string. It's moving in a circular path, and we're asked to look at when the rock is at point A. We're told that at that point, it's moving at a speed of 4 meters per second. We're asked to find the tension in the string. So coming over here to the picture, we've got the string here. We're looking for the tension in that string, and then we've got the rock up at the top at point A. So since we're looking for the tension in the string and the string is acting on the rock is our system in this case. So now that we defined our system, we can come down here to the first problem-solving step. And let's start by drawing our coordinate system. So since it's circular motion, we want to deal with the radial direction or the centripetal direction, and then the direction tangent to that, which will be the direction of the velocity of the object. So this is going to be point A here at the top of the arc. And we're going to have the inward direction towards the center of the circle be the positive R direction. And then again, the tangential means the spot that only touches a single point on that arc is going to be 90 degrees from this radial direction. And so that's going to point to the right, and I'm going to call that the positive T direction. You can choose the other ways to be positive T. It really doesn't matter. It just tells you which way your motion's going, whether it's clockwise or counterclockwise. So we've got our coordinate system specified. Now we can draw our free body diagram. So the question we need to ask ourselves is, how many forces are acting on this object? There's gravity pulling the rock downwards. And so that's the non-contact force that we always start with. And so we've got gravity pulling downwards, which is equal to, W is equal to mg. And we're told that the rock has a mass of 0.1 kilograms. So that's equal to 0.98 kilograms. Tension force. Is tension force acting in the upwards, so in the negative R direction, or downwards in the positive R direction? Well, at the top, the string is wanting to pull in that rock towards the center of the circle. So it's going to be pointing in the positive R direction. So we'll add that to where the weight force is. So T is equal to a question mark because that's what we're looking for. And so there's no more forces acting on the rock at this point. So we're done with our free body diagram. I'm just going to label a couple more things. We're told that the length of the string is equal to 0.6 meters. And so that's this length right here. I'm drawing it up on the picture here. That's L. And then we're also told at this point up at the top, the rock has a velocity of 4 meters per second. So now we've determined all the given information in the problem. What are we asked to find? Well, we're asked to find the tension, and we're expecting that to be a positive number, and it's going to be pointed inwards. And we're expecting units of newtons. So we're going to come down here to the second step. We are looking for the tension force. So we know we're going to want to use Newton's second law since we know the object's accelerating, to be able to solve for the force. So we're going to use Newton's second law, where we're summing the forces in the r direction, the centripetal direction, and that's equal to m, the acceleration in that direction, which is the centripetal acceleration, a sub c. And then the centripetal acceleration we know is equal to v squared, the tangential velocity squared, over the radius of the circular path. So coming down here to execute our plan, we're going to start by solving for the centripetal acceleration. And so that is this first step here. We know the tangential velocity, which is 4 meters per second squared, or 4 meters per second, and we square it. And then the radius of this circular path is just the length of the string. So that's 0.6 meters. And then we find an acceleration of 26.67 meters per second squared. Now that we know the acceleration at point A, we can use Newton's second law to solve for the tension. So that's this step here to the left. We sum the forces. Should the tension and the weight force be negative since they're pointed downwards? And so this is where you want to ask yourself that question, this spot right here. And you want to go back up to your free body diagram and see what coordinate system you chose. So we pointed downwards or towards the center of the circle as positive. So this is different than what we typically do for x and y directions, where downwards for the y direction is usually negative. But in this case, we're pointing towards the center of the circle, which we've called positive. So that's why these are both positive values. So that's a spot where you can easily trip yourself up. So just a word of caution there. Substituting everything we know in, we know the weight force is just 0.98 newtons. We know the mass, 0.1 kilograms. Multiplying the right side together and subtracting the weight force, we find tension. We find that tension is equal to 1.69 newtons. So the solution's complete. We found the tension. The sign is positive. We have units of newtons. And then the magnitude, is it reasonable? This is a hard one. I mean, the force is not that large. It's not a large magnitude, but you can imagine that this scenario is pretty similar to if you're like swinging a whistle for like a sports person or a lifeguard. You know, it's not a large mass. So this does seem like a reasonable answer.